Today, we're going to be looking at the wonderful world of quadratic functions using something called standard form. Now, we've already talked about standard form, which is not this. What is this form called? Y'all remember?
Vertex form.
All right. As mentioned, this puppy right here is called vertex form. The reason for it is because it quickly shows us the vertex. Right there, hence its name. So let's review here and see what we do get when we are trying to graph. So our vertex comes from here, h and k, -3, -4, opposite of what I see there. Axis of symmetry comes from here, x is -3, which is a vertical line. It opens downward because of that negative, and the pattern is 1, 3, 5, going in the downward direction. So let's go ahead and graph this guy right there. So -3, -4 lives right here. I'm going downward, and my direction is down 1, right 1. And actually, let me go ahead and graph that axis of symmetry so I can see what I need to bounce things off. Down 1, right 1 gives me those points. Now down 3, right 1, and then bounce across to get there. And I can even keep going. 5 puts me here, and then bounce across that, and then make the curve nice. We're going to take that equation, or the function we just used, and I'm going to rewrite it into a different form. And that form that we're going to write it in is going to be standard form. And in French, that is standard form. So in here. Now, you already know what standard form is when we talked about it a while ago, but we'll refresh ourselves momentarily. Okay, first thing. We have our original problem right here. That's vertex form. I'm going to expand the binomial, so this x plus 3 squared needs to be expanded. So I'll do that. Remember, we can do that really quick in our heads just by squaring, multiply and double, and then square. I'm going to bring down the -4 because it hasn't changed.
Your phone in class?
All right, so
Educational purpose.
let's now combine our like terms. These two puppies are like terms. So y equals, let me clean that up, equals -x squared minus 6x minus 13 there. And this here is called standard form because there's no parentheses. Everything's on one side, and the exponents are decreasing. The exponent is here 2, exponent here is 1. Here there is no exponent because there's no variable. So that's what makes standard form, like so. So, but let's take a gander up here. Here's standard form, and here's your graph. What here helps you out over here? One thing we notice here, what does the A? What does the A tell me about? Well, notice the A here is -1, and so is the A there. So both times the A doesn't change. It's the same. So the A does tell me about direction, and we could also talk about whether it is wider or narrower compared to the parent function. So A helps us out with that. Did anybody notice anything about this number right there over on the graph? So look here, -13 is right there, and that means C is my y-intercept. C is my y-intercept, and we'll unpack that in a little bit. C is always where it crosses the y-axis. That is, my graph does. So we're going to compare and contrast vertex form with standard form. So first off, vertex form. This is what it generally looks like. We have an A. Then we say x, forgot parentheses. Parentheses, x minus, don't forget there's an h there, quantity squared, and then plus a k right here. A tells me one thing. A times the pattern, etc., gives me the new pattern. Good. I'm going to write that in that box there. The reason for that is because this stuff in here is shared by both the vertex form and standard form. Good. So K does shift up or down. It takes the whole function and shifts it up or down. So you can talk about that as the up-down shift. And it's part of my vertex. There we go. So H here is part of my vertex, and H tells me how much I go left or right shift. Also known as a horizontal translation. So H is the axis of symmetry, so we write that as X equals H, and that's my axis of symmetry. So, as a reminder, if the absolute value of A is greater than 1, then this is going to be, it's wider. Narrower, more narrow. I didn't leave a lot of space in here, so I apologize. Next, we also know that if A is between -1 and 1, it's wider or more wide. So as I said, I'm going to try to squeeze it in here, that if A is positive, it opens up. And if A is negative, it opens down. So let's just finish up with the example right here. Good, that's good. Negative, not close. +5 and -121. So axis of symmetry is 5. We just take that 3 and we multiply it by the 1, 3, 5, and we get our new pattern. And this thing does open down because of this negative right there. All right, let's talk about standard form now. So this is what standard form looks like. So we've already said y equals, but now we have an a x squared plus a b x, and lastly plus a c. So a couple things we want to point out is everything that's true about A before is exactly the same as true now. If A is positive, this whole parabola opens upward. If it's negative, then the whole parabola opens down. We also know that A can help us create the new pattern or discover the new pattern. And we know it's more wide or more narrow based on what A is. So that we don't have to repeat. But let's talk about a few other things. C is important because that is my y-intercept. This is where the graph crosses the y-axis. The next part is, if I want to find the axis of symmetry, that uses a super secret formula, and it looks like this. X is negative b over 2 times A. Now the next part, of course, is what about the vertex? And the vertex is going to sound and look funny here. The vertex is this. First, it's whatever I just said, negative b over 2A, comma, and the y value is when you plug that back in. In other words, I take whatever number I get here and I plug it into the function to get it out. Not a very simple thing to look at. It's a little bit easier to work on when we do it. Let's walk through an example here, and we're going to start off finding the axis of symmetry. Finding the axis of symmetry. So in order for me to find the axis of symmetry, I need to use my super secret formula where it says negative b over 2A. And the key thing here is to know which one is your A, which one is your B, and which one is your C. So I'm going to list those over on the side, although just doing what I did here is identifying it. So A is positive 2, B is positive 4, and C is negative 5. To find the axis of symmetry, I'm just going to substitute these in. I say the negative of my b, which is positive 4. Got to watch out. Sometimes you'll have a double negative there. And then 2 times whatever your a is, in this case, 2. Now we simplify. I get negative 4 on top, 4 on the bottom. So my axis of symmetry is x is negative 1. Now to find the vertex, I have to take the negative 1 and plug the negative 1 into x here and into x there. So, you might want to write that down. Vertex, substitute negative 1 into the function. So, y equals 2 times negative 1, quantity squared, plus 4 times negative 1 minus 5. Keep going with this. So I get 2 times 1, because negative 1 squared is positive 1. That gives me a negative 4 with a negative 5. And in the end, I get negative 7. So my vertex is this negative 1 and this negative 7. Let's finish up. There's a few other things that we can gather from this. I know that this thing opens in which direction? It opens up. Because of the positive 2 there, this opens up. I could also say I know what the y-intercept is. My y-intercept is negative 5. Why? Because of that negative 5 right there. And lastly, I know what my pattern is. Based off the a being 2, it's 2, 6, 10, etc. All right, turn the page there. And look here. On this triad, it says, find the equation of the axis of symmetry and the vertex of the graph of each function. So please tell your neighbor, identify your A, B, and your C on number 1 there. Go. So my A is 1, B is negative 10, C is 2, and we're going to substitute in. Eyes on deck to see how we substitute in. Don't forget there's a negative to begin with, and then I have to put the negative 10 inside parentheses. Beware, there's a double negative there. Then down below is a 2 times A, and the A is just a 1. So just to finish this one up, we substitute in the negative 10 and the positive 1 there. And when we simplify, the double negative here becomes positive, and we end up with a 10 divided by 2, which is a 5. Now I take that 5 and I place it here and here, which looks like this. 5 squared minus 10 times 5 plus 2. 25 here, negative 50 there, 2 there, and that reduces to negative 23. So my axis of symmetry is x equals 5, and my vertex is the 5 here and the negative 23 here. And that's what we get. Final problems here. Just got to work on these ones here. Thank you.